Hi everyone. Um, I'm very glad to have this opportunity to participate in the KML hackathon. My sincere apologies for not joining you for the launch session yesterday. I had some commitments, but we are definitely happy to support this initiative as Ghana NLP, seeing that quantum and AI are all emerging technologies in Africa. And I believe that whatever we can do to collaborate and to learn lessons from each other as the AI and the quantum communities definitely helps us all to achieve our mutual interests. So yeah, with that out of the way, let me just say by way of introduction, my name is Mike Seth Owusu. I am from Ghana and I am the community lead for Ghana NLP. And we are participating in this program through supporting you to bring your knowledge of quantum into natural language processing. So, what is natural language processing? It sounds boring, but really it is the foundation of AI, right? So when you think about, you then go to ChatGPT and you type in a text and you get a response. That is NLP. It's essentially text generation, and it's really a direct result of NLP. So whenever you hear of models, large language models, when you see any model that works great, I think one thing you want to think about is the data sets that was used to create it, because data sets equals models. So the shape of the data set to determine how the model works, and that is essentially NLP, creating data sets that are used in models to make them do great things. And there's definitely other branches of AI that are not covered in NLP, vision side, some of the other aspects, video generation and all. But I think we see a great opportunity for NLP to be one of those breakthrough areas, right? Because if you look at our populations, we are constantly dealing with issues of connectivity and some of the places we want to reach, we are always having to think about, resource availability in terms of network and all. So if we can really do a lot of things with text, we have an opportunity to reach more people since it's not so heavy, it's not difficult to transmit. And when we talk about inclusion, one of the things NLP helps us to do to really drive inclusion is to um, help us to translate content, right? If you think about it, 90% of the world's knowledge is in languages other than our own, other than our African languages, right? And so we at Ghana NLP, we've been working on this way before ChatGPT became popular. And our goal has been to train models that can help to translate accurately content into Ghanaian languages. We are now supporting over 30 languages in Ghana and even outside Ghana. So we are really an African community. Uh, but there is an issue with language translation in that before you can, build a very good software which includes people, you have to have an element of language identification. So when you go into Google Translate, and you put in any text, right? There is the auto detect section, right, where you are able to detect the text. This may seem trivial, but it's very, very critical, especially when you're dealing with populations where you want them to have as minimum a low learning curve. You don't want to make it so difficult for them to onboard on the technology. So think about this. You want to deploy some technology in some remote area in say Ghana. Your technology is going to be like a clinic, a mobile clinic which is in a certain maybe say in the district assembly, and someone can just go there, talk to it, say some words, say and be able to identify themselves and get information about their health. This sounds great and it's very doable, but one of the first things you have to deal with is be able to identify language. Because someone you in any area you go to, you may have different languages, right? You may even have not just different languages, but you may have not just someone speaking, but you may have another something else, a noise, what we call a noise. How do you detect language, your interest, your language that you are interested in from the other languages and the noise that you're not interested in, right? So that is really, I guess, the essence of being able to build models that can identify, language from the beginning. And so if you think of it such a, like the example I gave you, essentially someone goes to this kiosk, say this health kiosk, they speak to it, and then what you don't see in the background is there's a transcription model that is transcribing it to text. And then you are going to have a model that first of all detects the language, makes sure that it is indeed the language you're looking for. It sends it to the model in the backend. Maybe you may have multiple models, right? So you may have different language models there. So it takes it and sends it, routes it to the right model so it can actually do the correct translation. So essentially, we have put together a data set that allows you to, run code using sentences, input sentences, and then this data set is mainly bigrams, right? So when I say bigrams, we are talking about just sentences, but sentences that have been cut into two words, so two-word pieces. So it's not full sentence, it's more of chopped up sentences, if you will. And this is a technique that has been proven to work very well with machine translation evaluation. So essentially, when we train models, this is how we check to see if the models are performing well. And this is essentially what we are also trying to apply here to identify language. We have put together notebooks for you, which you can use. If you read the challenge brief, essentially you're going to be able to use that notebook to test to see how the data set works. And then we have two notebooks that you're going to be able to use. One of the notebooks allows you to run a test on a single input sentence. And then you have another notebook that allows you to run a test on multiple sentences using that data set we have provided. Your goal will be to see how you replicate what we have provided for you in those notebooks using Quantum. Essentially, we are running code that allows us to calculate what is called BLEU score. You don't need to go into the details of that, but essentially, to simplify it, we are taking the patterns, right? So if you take a sentence, what is the pattern of words in terms of how words succeed each other? So this bigram data is essentially if you have one sentence that says Kofi is a boy, in our data set, that sentence becomes multiple rows. So you're going to have Kofi is as one row. You're going to have is a as one row. You're going to have a boy as another row. Now that kind of creates a certain signature of the sentence, right? So when you pass an input sentence through this bigram data set, it is able to look at the patterns of that input sentence, even if it is different from any of the sentences that have been used to create that data set. It's able to kind of have this understanding of the patterns, and it's able to say, this pattern actually looks like English. This pattern actually looks like French. It looks like Tree. It looks like this language, right? So this is essentially what the code does, as you see in the notebook, and feel free to, of course, explore, look at the code. Maybe it's not even perfect. You can do it better. But the goal, as you've already seen, is to essentially be able to accurately identify, first of all, see how you make it work with a single input, and then you see how you can make it work with multiple inputs. It's as simple as that. This is the goal. So we are going to be available to support you. If you have any questions, feel free to reach out on the Discord server. Tag me. My name is Kofi. Kofi 8 something, but I am Kofi on the Discord server. So look for me there and then tag me if you have any questions, and we'll be able to support you. So wishing you the best going forward in the challenge, and we are hoping to see some great results after the whole 10 rounds. So cheers.